PhD, and this video is directed to my Denmark calculus class. This is just a problem that we've been working on, and it's kind of to review the concept on finding the equation of a line, first the slope and then the equation of the line that's tangent to the graph, using the rules for the derivatives of a function. So let's get started. This question says find the equation of the line that's tangent to the graph of f of x equals x squared minus 6x plus 8 at x equals 3. So the best way to approach this is first let's find f prime of x. And so our function is f of x equals x squared minus 6x plus 8. And now we're going to use the derivative rules. It says we can now take the derivative of each term, and that will be the derivative of the function. So the derivative of x squared would just be 2x. The derivative of minus 6x is just minus 6. And then the derivative of 8 is 0. And so therefore we actually have our derivative function, f prime of x is equal to 2x minus 6. And so now let's figure out what that slope is. Since we have the derivative formula for the slope at every point, we can now calculate the slope of that tangent line when x is 3. And so f prime of 3, we're going to use that function, substitute 3 in there, and I'm getting 6 minus 6 is equal to 0. And so that's just great. That lets us know that at x equals 3, the slope of the tangent line is 0, and we now know that that's actually a vertex point. Okay, so to get the actual coordinate pair, we can just plug f of 3 into the original function. I'm getting 3 squared minus 6 times 3 plus 8, and that's just 9 minus 18 plus 8. And we keep solving, we're getting negative 9 plus 8, and I have negative 1. And so now I know that the vertex point occurs at x3, y negative 1, and the equation of that line, well, since it's a horizontal line, it intercepts the y-axis. It doesn't intercept the x-axis, it intercepts the y-axis. And so the slope is 0, but it intercepts the y-axis at negative 1. So the equation of that line is just y equals negative 1. And that's the equation of that tangent line at x equals 3. And so that's the solution that we were after in this particular problem. So that wasn't that interesting because when we calculate this derivative, we actually got that f prime of 3 was 0, which was a little unexpected. But what would have happened if we found for x equals, say, negative 1? What would be the slope of that tangent line when x is negative 1? It should be fairly negative, since we know that our graph has a vertex point at 3 comma negative 1, and that's the turning point. And these parabolas are symmetrical. And so at 3 and negative 1, we're here. And that's also the axis of symmetry. And if we were to factor this, we could find the x-intercepts. Okay, it factors into x minus 4 times x minus 2. And if that's our f of x. If we were to set our f of x equal to 0, we could get the two values pretty quickly. So our two x-intercepts would be x is 4 and x is 2. And so we know that at 2 and at 4, our graph has intercepts. And this is just a rough sketch of what the graph is going to look like. So at -1, the slope of that tangent line should be very negative. And so what we're going to do is use f prime of x is equal to 2x minus 6. And I'm going to figure out what f prime of -1 is. I'm getting 2 times -1 minus 6. So that's -2 minus 6. And that's just -8. And so the slope of that tangent line at that particular point is at -8. And we actually need a point to use the point slope formula. We need a point on the graph. We know at x is -1, so let's find f of -1. F of -1. Now, if we plug -1 into our original function, we're going to get -1 squared minus 6x. Actually, that's 6 minus 1, 6 times 1, plus 8. Let's simplify that. That's 1 plus 6 plus 8, and that's just 15. And so the point is at -1 and 15, and the slope is at -8. And so we have a point and we have the slope. So we can use the point slope formula to write the equation of the line. So that's the y minus y1 is equal to m times x minus x1. And so let's plug in our point and our slope and solve this. We get y minus 15 is equal to -8 times x minus a -1. Let's just keep going. That's y minus 15 is equal to -8 times x plus 1. And there's our equation of a line. We can put it in slope intercept form. Let's just do that. That's the y equals mx plus b form. We should be able to do that right away. Let's do that by solving for y. Simplify the right-hand side. I get y minus 15 is equal to -8x minus 8. And then when you bring over that 15, we're getting y equals -8x plus 7 when we bring over that 15. And there you have it. That is the equation of the line that's tangent to the graph at x equals -1. And it is pretty consistent with what we know about the graph. We knew that the slope would be a very negative, very steep negative line. And the rate of change is actually -8 per x, per 1. So -8 over 1. And so that's going to do it. This video serves as just a good refresh of some of the concepts that we've been working on. And taking it a little bit step further, discussing the equation of that tangent line. I hope this was useful, and as always, if you have any other requests or comments or feedback or suggestions, please reach out to me at once. Have a great day.